Eutectic materials, specifically low melting point alloys, play a crucial role in motor overload protection as referenced in the National Electrical Code Handbook. These alloys are often found within bimetallic overload relays, which are designed to protect motors from excessive current draw that can lead to overheating and damage. The fundamental principle behind a bimetallic overload relay is the differential expansion of two dissimilar metals bonded together. When subjected to heat, these metals expand at different rates, causing the bimetallic strip to bend. This bending action is used to trip a mechanism that interrupts the motor's power supply. Now, where do the eutectic materials come into play? In some overload relay designs, instead of relying solely on the direct heat generated by the motor current passing through a heater coil, the bimetallic strip is indirectly heated. This is achieved using a small heating element and a capsule containing a eutectic alloy. A eutectic alloy is a mixture of metals that has a sharply defined melting point, lower than the melting points of its individual components. A common example is an alloy of tin and lead. The eutectic temperature is the specific temperature at which the alloy transitions directly from a solid to a liquid state. The selection of a specific eutectic alloy is critical for the overload relay's performance. The alloy's melting point is carefully chosen to correspond to the motor's thermal characteristics and desired overload trip point. Here's how the system typically works. When the motor current exceeds its rated value, the heater coil generates heat. This heat is transferred to the capsule containing the eutectic alloy. As the alloy's temperature rises and reaches its eutectic point, it melts. This melting process triggers a mechanical linkage or a spring-loaded mechanism that, in turn, causes the overload relay to trip. The tripping action interrupts the motor's power supply, preventing further overheating and potential damage. The use of eutectic alloys offers several advantages in motor overload protection. Firstly, it provides a relatively precise and repeatable tripping characteristic. The sharply defined melting point of the alloy ensures that the relay trips consistently at the predetermined overload level. Secondly, the indirect heating method allows for better thermal isolation between the heater coil and the bimetallic strip. This minimizes the influence of ambient temperature variations on the relay's performance, resulting in more accurate and reliable overload protection. Thirdly, the eutectic alloy acts as a thermal storage medium. It absorbs heat during overload conditions, providing a time delay before the relay trips. This time delay is essential because it allows for short-duration overloads, such as those caused by a motor starting to pass without tripping the relay. Without this time delay, the motor would be unnecessarily shut down during normal operating conditions. The design and selection of the eutectic alloy are critical aspects of the overload relay's overall performance. Factors such as the alloy's composition, melting point, thermal conductivity, and thermal capacity must be carefully considered to ensure that the relay provides adequate protection for the motor. Furthermore, the overload relay's tripping characteristics must be coordinated with the motor's thermal damage curve. The thermal damage curve represents the relationship between the motor's operating temperature and the time it takes for the motor to reach a point where damage occurs. The overload relay should be designed to trip before the motor's temperature reaches this critical point. The National Electrical Code, or NEC, provides specific requirements for motor overload protection. These requirements are intended to ensure that motors are adequately protected from overheating and potential damage. NEC Section 430.32 covers motor overload protection. It mandates that each motor shall be protected against overload by one of the following. Firstly, a separate overload device that is responsive to motor current. This device shall be selected or adjusted to trip when the motor current exceeds a predetermined value. Secondly, an integral thermal protector that is factory installed in the motor. This protector shall be designed to automatically trip the motor when its temperature exceeds a safe operating limit. Thirdly, a protective device that is part of the motor controller. This device shall be designed to trip the motor when its current exceeds a predetermined value. The NEC also provides specific requirements for the selection and sizing of overload devices. These requirements are based on the motor's nameplate current rating and service factor. The service factor is a multiplier that indicates the motor's ability to operate continuously at loads above its rated horsepower. The NEC allows for the use of different types of overload devices, including thermal overload relays, magnetic overload relays, and electronic overload relays. Thermal overload relays, which utilize bimetallic strips and eutectic alloys, are a common choice for motor overload protection. The selection of the appropriate overload device depends on several factors, including the motor's characteristics, the application requirements, and the prevailing environmental conditions. When selecting an overload device, it is essential to consult the manufacturer's specifications and recommendations. The manufacturer's data will provide information on the device's tripping characteristics, operating temperature range, and other important parameters. In addition to selecting the appropriate overload device, it is also crucial to properly install and maintain the device. The overload device should be mounted in a location where it is readily accessible for inspection and maintenance. It should also be protected from dust, moisture, and other contaminants that could affect its performance. Regular inspection and testing of the overload device are essential to ensure that it is functioning properly. The overload device should be tested periodically to verify that it is tripping at the correct current level. If the overload device is found to be defective, it should be replaced immediately. Proper motor overload protection is essential for ensuring the reliable and safe operation of electrical equipment. By understanding the principles of eutectic alloys and bimetallic overload relays, and by following the requirements of the NEC, technicians and engineers can effectively protect motors from overheating and damage. Eutectic alloys are used in various applications, including soldering, brazing, and thermal fuses, due to their distinct melting points. In motor overload protection, they are a reliable method for indirectly sensing heat and tripping a circuit. In summary, the low melting point alloy, acting as the eutectic material, melts at a specific temperature corresponding to an overload condition. This melting action triggers the overload relay, disconnecting power to the motor and preventing damage. The precise melting point is the crucial attribute that enables accurate and repeatable overload protection. The NEC serves as the guiding document for proper implementation, emphasizing the need for carefully selected and maintained overload devices. This ensures motor safety and reliable operation.